Okay, this is page 521, geometry, similar triangles, the SSS and the SAS similarity postulates. Okay, as you can see, I've written, determine whether the triangles are similar. If so, write a similarity statement and explain. Okay, before we get to that, I'm going to take that away. We're going to come back to that, so don't panic on that you didn't get everything written down. But before we get to that, we're going to talk about two new concepts today about similarity. The first one is the SSS similarity, and this is a theorem. And you got to have this symbol, otherwise everybody thinks it's a congruency. So the SSS similarity theorem says if three sides of one triangle are in proportion to three sides of another triangle, the two triangles are similar. Okay, the book says it if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Now, when you do this, okay, if I do this, I'm going to draw two triangles. I'm going to call this A, B, and C, and then D, E, F. Okay? What happens is, and sometimes this is really hard to tell, but if they don't tell you, you have to match sides up based on eye length. And that's something that we haven't done a lot of, but you take the largest over the largest. So in this case, AB would have to be similar to D, or would be over DE, would equal BC over EF equals CA over, this is what? This is F. F1, okay? So this side over this side, this side over this side, this side over, excuse me, this side over this side, this side over this side, this side over this side, okay? So you go from one triangle to the other. And so we would say triangle A, B, C is similar to triangle D, E, F by the SSS similarity theorem, okay? And they have a proof of that. That's why we call it a theorem. Okay? All right, now I'll go back to this one. It says determine whether the triangles are similar. If so, write a similarity statement and explain. You must explain if they are similar. If they're not, you don't have to. So well, yes you do. You just say the sides aren't in proportion. Okay? So let's take a look at these two triangles here, okay? What side, we'll start with the 6. What side matches the 6?
Where's the 6?
Up here?
Oh, sorry. Yeah, 15.
Okay? You say 15, right? What side, we want to check this, right? What side matches the 5?
12.5.
How do you know this?
Because if you were smallest.
Smallest to greatest, okay? Or in this case, we're not actually going in any order. But notice that 16 goes with the, 6 is the middle number, so it goes with 15 is the middle number. 5 goes with the smallest because they're both the smallest. And what would be the largest? What should be on top?
What? I mean, 8?
8 over?
20.
All right, now let's check it. Okay, now, how do you check it? Okay, that's good. Nobody knows. Okay, get your calculators out. What you do is, the quickest way, I think, you can simplify each fraction if you want, but there's another way too. I can take cross products, because in proportions, the product of the extremes is equal to the product of the mean. So I can take 6 times 12.5. What do I get? 6 times 12.5. What do I get?
75.
75. Would you take 15 times 5? What's that?
75.
That's right. So they're both equal, right? Therefore, these two are in proportion. However, you must take these two also, right? Take 5 times 20. What is it? 100. Now, most people think, oh, you didn't get 75, you're in trouble. No, you might get different numbers on this. What's 12.5 times 8? 100. So now all the sides are in proportion, aren't they? And you can do this one too. 20 times 6 is? 20 times 6 is? 120. 15 times 8 is? 120. So all the sides are in proportion. So this is yes. Now, it's very important. Yes, by the SHsS similarity theorem. Okay, so I have explained it. This is my explanation. I've answered yes or no. Now I need to write a similarity statement. Okay, so I'm going to go PQR is similar to what triangle? What matches PQ? ST? Okay, so it goes STR. You have to get that statement correct. It's just like congruency. Okay? Any questions? All right. Let's go to this one. These two triangles. What's the smallest on this one? Let's go smallest to largest on this. What's the smallest on this triangle? This one here. 2.4 over 1.8. That's the smallest on that one. That should equal, question mark. We're trying to see if it equals it. We come back over the next one is what? 3.5 over what? $2.7?
Yes.
Okay. And then we have the last one is 4.4 over what? 3.6. All right. I need some multiplication here. What is 2.4 times 2.7? 6.48. Do you agree? Does that equal 1.8 times 3.5? 6.3 does not equal. So this is no. The sides are not in proportion. Okay, that's your explanation. Any questions about that? All right. Okay, so now we're going to look at numbers. I'm on example 2 on page 522. Example 2 on page 522. It says, I have a graph of it. It says determine whether triangle ABC with vertices A and -2, 1, B 3 and -1, and C 1, 4 is similar to triangle XYZ with vertices X is a -2, 4, Y is 2 and -6, and Z is a -8 and -2. Explain your reasoning. Okay? All right, here's the two triangles. Now, it is really hard to see what matches what, doesn't it? I don't know which is the longest because they all kind of, okay, so what we need to do is just take a side and start figuring out what the lengths are. And we use the distance formula, okay? So I'm going to start with, I'm going to do it on right here, okay? I'm going to start with AB. So I want to know the distance AB. So what I'm going to do is, remember the distance formula? Let me write the distance formula. Distance equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. We've used that a lot, haven't we? Yeah. Okay, so what I want is Kellen and Aubrey, you to do AB. Okay? Connor and Dylan, you do BC. Okay? And Chinny and Nelcha, you do AC. Okay? So that takes care of the little triangle, correct? All right, on the big triangle, I want Tyra and Kagan, I want you to do XY, right? And then I'm back over here with Kellen and, Kellen and Aubrey. Will you do YZ? So you'll have 2. And then Connor and Dylan, will you do XZ? Okay? All right, when you get a distance, leave it in simplest radical form, would you please? I might help out with the bottom 2. XZ.
That's what we got. Now I have to use YZ. Hey, what'd you get?
You just had BC and Connor.
And YZ. No, and, and X, which one did you have?
We're doing YZ.
YZ, XZ, so I'm working on it, but I want you to check it, make sure I'm right.
No.
Can't 2 go into it?
Okay, what'd you get for AB?
Screw it, 29.
Anybody get BC?
Yeah.
What was it? Okay, so those are equal, right?
Yeah.
Okay, and then AC,
3 screw it, 2.
you square it 2, okay? Did anybody get XY?
We didn't square up 116.
160?
Yeah,
116.
116. What did you get for YZ?
Same thing.
Same thing?
Yeah.
Okay. All right, so let's look here. We got the square root of 29 over the square root of 116, right? And that equals the square root of 29 over square root of 116. That's true because that times that is that, right? So that's true. Is equal to 3 square root 2 over 6 square root 2, which that cancels. That actually equals 1/2, right? So 1 times that. Is that right?
What is the middle bottom one?
Yeah. 6, is it still
That's
square root of 116?
this one. That's square root of 116. So if I take 1, I'm doing this one right here, guys. So I get 2 times the square root of 29. Does that equal the square root of 116? Do that on your calculator. It does. Now, this would be the square root of 29 times 2, which is the same thing as the square root of 116. So, yes, these two triangles are similar by the SSS, right? Right?
Yes.
All right. Now, the question is, well, actually, it's just triangle ABC then is similar to what? XYZ. Pretty straightforward. So you see how you do it? It's a lot of work, isn't it? I only got you doing one of those, okay? All right, any questions? Okay. Well, turn to page 523, and there's another theorem that says this. This one's not used as much, but it's still used. It's called the SAS similarity theorem, and it says if the lengths of 2 sides of one triangle are proportional to the lengths of 2 sides of, or we better put two corresponding sides. Got to be careful there because there's a third side, isn't there? Of another triangle. And the included, this one's a long one, angles are congruent. The two triangles are similar. So let's say I have something like this, right? And I have, this is 4, and this is 6, and this is 6, and this is 9. Okay, if I take a look at these two triangles, this angle here and this angle here are congruent, right? And the sides that make up those, if you look at this, the shorter one, 4/6, does that equal 6/9? That's the question. Nelcha, 4 times 9 is?
36.
And 6 times 6 is?
36.
So yes, these two triangles are similar by the SAS similarity theorem. Does that make sense to you? All right. They had, this is kind of a unique, let's take a look at this one. This is example, example 3B on page 524. They have this point to be A, this point to be C, and this point to be B. And they do this. This is E, and this is F. Is that right? This is 4, this little piece here, and this is 5. This is 8, and this is 10. The question says, are triangles are similar, and what triangles are similar, and why? Okay. Now you can see that we have triangle AEF is a little triangle, correct?
Yes.
And the big triangle is ACB, correct? And you can see that they share angle A. So they have an angle that is congruent. So the sides that make up A are 8 over what? The little triangle, 8 over what? Be careful. 8 over what? What's the whole length? 12. Does that equal, do you see where we got 12?
Zero.
You take 8 plus 4, right? Does that equal 10 over what? 15. So 8 times 15 is what?
120.
120. And 12 times 10 is?
120.
120. Now, so we want to say the two triangles, so this is yes, by the SAS similarity theorem. But now we need a similarity statement, don't we? Okay, so I'm going to start by saying triangle AEF. What is that similar to?
ACB.
ACB. Okay? And there's your similarity statement. Alright? So on page 525, they have the 3 listed down there. They have the AAA similarity postulate, the SSS similarity theorem, and the SAS similarity theorem. Did you get that? Alright, so your assignment is page 526. I'll have Chinny write this on the board. Page 526. 9 through 18. 9 through 18. Okay? There's only one that you're going to do with the points. Okay? 9 through 18. The rest of them are just, are they similar? How do you write it? Okay? When is that due?
Monday. Nope, Tuesday.
That is due Tuesday. Okay?
Tomorrow's a work day?
Tomorrow's a work day. Alright? It's a work day. So if your geometry is done, find something else to do. Not talk about the things that you discuss normally.